Hey guys, I giving you your lesson for today. Now you're going to be like, what? Why are you at lesson 10? So I went through the lesson this weekend, or not the lesson, but the test that's going to be upcoming, and it's on volume of a right rectangular prism, I believe it was. And that is not at all on the test. There was one lesson that I didn't go over that I didn't think was on the test, but it is, which was a little bit of a change from last year. Last year, they didn't have too much of this lesson 10 stuff, so that's why I had skipped it. So anyway, I am going back. We're not going to do the last two lessons in this module, but we are going back to this lesson 10 for today. I'm not sure just yet what we're going to be doing as far as tomorrow's lesson, but that will be upcoming. So go ahead and find your way to lesson 10 and we will go over this lesson. So this is angle problems and solving equations. So this is kind of where in the module where it got really weird, how it went from working on equations to all of a sudden we're working on angle problems. So really with angle problems, we can make them as equations. And so that's what we're going to get into in this lesson. But first of all, we have to know a little bit of the vocabulary with this. So the first one here, and make sure that you're writing this in your workbook so you have this. But the first one is the adjacent angles. Adjacent angles, where you have two angles that are right next door to each other that have a common side. So we have in here angle BAC. It's right here, angle BAC. And it is right next door to angle CAD right here. And it has a common side, which is this line here, which is called AC. And when you have these two angles here, they are what is called adjacent angles. Okay. And yeah, I think that's about it for this one here. So this one is actually a really important one to know. Make sure you know adjacent angles. All right. Of course, as you know, you can always pause a video so that you can write your notes on here. Okay, so let's take a look at vertical angles. Vertical angles is always something good to know, not just for 6th grade, but for 7th grade, 8th grade, and into geometry as well. So basically, when two angles are vertical, or they are vertical opposite of each other, and they end up forming two pairs of opposite rays. I think I'm actually kind of saying that wrong. It is kind of, you might actually see at the top of my screen, it's almost 11 o'clock on a Monday night, so I'm kind of tired. So let me just read what I have in here. So two angles are vertical angles or vertical opposite angles if their sides form two pairs of opposite rays. So you can see that we have these two lines here and they cross each other. Okay, and you're seeing here that this angle, which is, we can look at it as angle A, because they do have it marked right here. We can also call it angle, and see how I'm writing? It's not the less than symbol. It's written a little bit different. If I use so the bottom part is actually, see, that's straight, and then the top part kind of goes up at an angle. So that is actually the symbol for angle. And the angle is angle DCF. We always have the vertex of the angle, which here is C. That is always there in the middle. Okay, we always start with D, C, and then F. We could also call it FCD as well. But typically, whenever you see an angle being named, they'll always start with, well, D comes first in the alphabet. Okay, but you could call it FCD and you would still be 100% correct. So we have this angle A, and see how it is on opposite sides. It's a cross, and it's actually what's called vertical from angle A, and it is angle B right here, or it is called also angle ECG as well. Excuse me, guys. And when we see vertical angles here, we actually know that the measure of those angles are equal to each other. So whatever angle A is, that means that's what angle B is. So for example, if I said that angle A here was, I don't know, maybe 20 degrees, that means that the angle B has to be 20 degrees. Why? Because they are vertical angles. There's actually another set of vertical angles here, and that is right here. And then what is opposite of it is over here on this other side. And so that's another pair of vertical angles there too. Okay, so let's go to angles on a line. So when we have a line such as this line right here, we know that when we measure it, we took a protractor here and I started measuring it. I started from here and moved, looked all the way around and to back over here, I'd find that that is 180 degrees. So basically a straight line is 180 degrees. It's one thing you should always remember. Now we have an angle here, a ray I should say, that is bisecting that, that line ABD. And so it ends up forming two angles. We have angle A and we have angle B right here. And so basically when we add up the measure of angle A and angle B, both of those, they would equal 180 degrees. Okay. All right. So angles at a point. So we have basically these line here, we have a line here, we have a line here, and they're all starting from this point A here. All of those lines are rays and they're coming out from that point A. And basically, if we take the measure of all of these angles, like this angle A, we added up angle B, we added up angle C, it would equal 360 degrees. Okay, so there's our vocabulary for this lesson. So let's go ahead and go to the next page and use that to help us to be able to find vertical angles and all of that kind of stuff on this diagram. So what I want you to do is I want you to pause the video and I want you to name all the angles that are vertical, adjacent, angles on a line, angles on a point. Let's go ahead and do that now. All right, so you should have paused the video and taken a look at our diagram to find all these different angles. So vertical angles, here they are. Angle AEC and angle BED are vertical. Also see that CEB and angle DEA. So adjacent angles, here are a couple of them. Angle AEC and angle CEF. We also have angle CEF and angle FEB. Okay, angles that are on a line. Here we are, angle BED, angle DEG, and angle GEA. So all of those are on a line. We also have angle AEC, CEF, and angle FEB. Okay, so angles at a point. So a lot of them here, if you take up all of those lines and add them all up, they are angles AEC, angle CEF, angle FEB, angle BED, angle DEG, and angle GEA. All right. So let's go ahead and move on down here to example 1. Excuse me, guys. All right, so take a second here to estimate what you think the measurement of that angle X would be. This is not a precise, this is just a guess on what you might think. So, when I'm going to make an estimate, I know that the line is 180 degrees. And I know if I drew a line here straight up, I know that's not perfect, and I put that little box, that box would actually tell me that that's 90 degrees. And that line almost looks like it's halfway in between there. So I would say half of 90 is 45. So I'm going to do a guesstimate of 45 degrees. That's my estimate. So they want us to describe the angle relationships in the diagrams. They just basically want us to describe, hey, what's going on here? So this is what I have. So we have angle BAC and angle CAD are angles on a line, and their measures have a sum of how much? 180 degrees. So what we're going to do, it says write an equation. I know a lot of you guys are like, I already know what it is. I'm going to figure it out. But this whole unit is about expressions and equations. So with that in mind, we need to put together an equation. So since we know that this line is 180 degrees, our equation is going to equal 180 degrees. Well, we know that these two angles, we have the two angles on a line, they equal 180 degrees. Well, if I just add them all up, then they will equal the 180 degrees. So we have x plus 132. One of the angles was given. So here is our equation. So now we just go through and we solve it. So we get x is equal to 48. So what we are saying here, the measure of angle BAC is equal to 48 degrees. So just a really quick here in geometry, M here is measure. So basically this is saying the measure of angle BAC is equal to 48 degrees. Okay. All right, so let's go ahead and go to the next page and work on the next one. All of these questions that we're going to go through work the same way. They want us to be able to describe what is going on in the diagram and then find certain measurements of some of the angles. Okay, so think about how you would describe that diagram and then write it and pause it so you have time to do that. Okay, so if we're going to describe this, I would put the angle of BAC, angle of CAD, and angle DAE are angles on a line and their measures have a sum of 180 degrees. So you might have wrote it differently, and that is perfectly fine as long as you have something that's sort of in that manner there. So an equation, go ahead and write your equation, what you think that is. Then go ahead and solve it, all of that, and pause it so you can do that too. Okay, so with putting together the equation, it is on a line. These angles are all on a line, and so we know that in our equation it's going to equal 180 degrees. So we have one angle here that is saying that is 3x degrees. We have another angle here, and we don't have the measurement, but this little box tells us that that is 90 degrees. Then we have a third angle here, and they say that is 2x degrees. Okay, so what we need to do is we basically just need to add up all three of those angles, and they need to equal up to 180 degrees. So here is our equation. So we would write 3x plus 90 plus 2x equals 180 degrees. So now we're going to go ahead and combine like terms. 3x plus 2x gives us 5x plus 90, and that equals 180. So I'm going to go ahead and subtract 90 on both sides. We get 5x is equal to 90. And then we're going to divide both sides by 5. We're given, that is x equals 18. So we're not done here. Yes, we did find out that x equals 18, but what is the measurement of this angle right here? Well, okay, this is what we must do. So we have angle BAC. It says it is 3x. Well, I know now what x equals. X is equaling to 18. So we're going to plug it in. We're going to plug it in there for x. So we put 3 times 18, and that equals 54 degrees. So this one here is 54 degrees. So the last one, we have angle DAE, and they said it was 2x. So 2 times that 18 gives us 36 degrees. This one here is 36 degrees. So if we add up 54, 90, and 36, they would all equal up to 180 degrees. Okay. All right, so I want you to pause the video. I want you to do this example here. And when you come back, I will work out the problem for you. All right, so with describing this one here, we have angle AEL and angle LEB are angles on a line, and their measures have a sum of 180 degrees. We can also say that in here that angle AEL and angle KEB are vertical angles and are of equal measurement. Okay, so because this angle right here is 144, and right here, Y, that is vertical of that angle here. So I know that Y equals 144. I'm going to mark that down here. Y equals 144. Measure of angle KEB equals 144 degrees as well. And why do I know that? It's always very important to actually know why, and that's going to be especially important when you get into geometry in high school. Okay, guys? Why? Know why. And that is because of vertical angles are equal. Okay, so putting together our equation, we can do x plus 144 equals 180. So we can go ahead and solve this now. This one's a pretty quick one to do here. So I have x is equal to 36. So we can say that the measure of angle LEB is equal to 36 degrees. There we go. And I would like you just to do one more. Go to the next page to example 3. So go ahead and just pause the video. Again, work this problem out. And then also the equation. Okay, so just for time-wise, I'm not actually going to write down the diagram, the description, but basically we have angle GKE, angle EKF, and angle GKF. Those are angles at a point, and their measures have a sum of 360 degrees. So, we have 135 here. We have x. We're going to have to find that. And we have our symbol here telling us that this here is 90. So we add that angle, we add this angle, we add that angle, and they all are around this one point here at K. So we know that we can actually add all those up, and they're going to equal 360 degrees. So our equation would be x plus 90 plus 135 is equal to 360. So we'll combine like terms. So x plus 225 equals 360, and then we're going to solve for x. So we have x is equal to 135. So the measure of angle EKF is equal to 135 degrees. Okay, so let's see, what do I want you to do for homework tonight? So let's go on over to their problem set. Here we go, here it is. So let's have you do question 1, question 2, question 3, and question 4. Let's see what we got on the next page. And let's have you do 5. And I think that's good. We'll just stop right there. So do numbers 1 through 5. Okay, guys? So hopefully, I like always doing something with geometry, so hopefully you guys enjoyed it as well. All right, we'll see you guys later. Bye-bye.